So, very good morning all. My name is Dr. D. Srikant. I'm an assistant professor in Department of Petroleum Engineering. Yes, my topic is a natural gamma ray spectrometry approach to determine the clay mineral composition and depositional environment. Depositional environment in the sense from where the sediments are drawn. That is the depositional environment. And the clay mineral composition. We have several clay mineral composition like kaolinite, montmorillonite, illite, mica, chlorite and all. Now why is it so important is this way of determination of clay mineral composition and depositional environment will help in the reservoir modeling. So this work I have done for Ramnath subbasin, which is a part of the Kaveri basin in Tamil Nadu. A brief gist about the Kaveri basin. Now it is on the east coast of India and it extends from Pondicherry in the north to Tuticorin in the south, which is a part of Tamil Nadu, and it is also present in the offshore. In onshore, it is present from Pondicherry in the north to Tuticorin, and in the offshore, it stretches into the waters of Bay of Bengal, Park Strait and Gulf of Mannar. This particular Kaveri basin is in between India and Sri Lanka. So the basin is thus an intra-tectonic downland. Now, the early shear drift extension faulting. Faulting in the sense a division of a bed. That extensional faulting has initiated and it has happened during the late Jurassic to early Cretaceous. These are nothing but the geological time scales. Okay, so that has led to the evolution of the Kaveri basin. Now, basin has been divided into grabens and hores. What are grabens is nothing but it is a depression where the sediments have come and deposited in it. Hores are nothing but the basement heights. Basically, they are igneous rocks, and the sediments are drawn from the igneous rocks and deposited in the grabens. So we have all these sort of grabens. So these are all subbasin. Annular Pondicherry subbasin, Kankobar subbasin, Tanjore subbasin, Nagapattinam subbasin, Pape Ramnath subbasin, Mannar, Gulf of Mannar. Mannar is Gulf of Mannar subbasin. So all these are different subbasins which constitute the Kaveri basin. And the hores are nothing but basement heights from where the sediments are drawn. These sediments are drawn via wind, water and other things. So, as far as Ramnath subbasin is concerned, on the northwest we have Pattukottai Mannargudi Ridge, and on the southeast we have Mandapam Delft hose. And the sediments are basically drawn from Pattukottai Mannargudi Ridge, which is nothing but the basement height. Now, this to have a brief gist about what is Ramnath subbasin. It is the southernmost of the grabens with proven hydrocarbon reserves. So in Ramnath subbasin, we have mostly hydrocarbons, that is gas, with very little presence of oil. So the Ramnath subbasin is, as I told you, Pattukottai, Mannar and Mandapam. So this basin has asymmetric half graben. It is not symmetric. It is asymmetric half graben geometry with well-defined normal faults developed along the western margin. So it has a well-defined graben floor containing late Jurassic to Quaternary. Quaternary in the sense very recent sediments. So Jurassic, late Jurassic means during the Jurassic animals are present. The sediments were drawn from Patikote Manargudi Ridge started from that time itself. Okay, so that is late Jurassic to Quaternary sediments. So now I will start with the NGS applications. This is the work, the first of its kind work. This work which I have carried out in the Kaveri Basin, that is Ramnath Parkway Sub-basin. Now, it is a part of well logging. So there are various logs in well logging, starting with gamma ray, spontaneous potential, caliper. Then we have 3 different types of resistivity logs. Then we have porosity logs, that is density, neutron, and sonic. So all these are conventional logs based on which we determine lithology, based on which we determine whether there is a presence of hydrocarbons or not. Then we determine permeability, then the net pay thickness, that is the thickness of the reservoir, and all that. Gamma ray. In the gamma ray also, it is subdivided into 2 types. Okay. Now one is the conventional gamma ray. Conventional gamma ray we basically use to differentiate the lithology. That is, in shales, gamma ray reading is high, and in sand, gamma ray reading is low. Why? It is because of the presence of the radioactive elements. There are basically 3 radioactive elements, that is thorium, potassium, and uranium. These 3 are the radioactive elements because of which we get high radiations. And these radioactive elements are present mostly in shales. It occurs very occasionally in sands, but mostly it is present in shales. Now, uranium is present because of the organic matter which is present in the shales. Okay, if the organic matter content is high, uranium content reading would be more. So, hence, there is a term called SGR. SGR is nothing but the spectral gamma ray, that is, it removes the gamma ray's contribution from the uranium. We do not want the uranium reading because it is related to the organic matter, whereas thorium and potassium, it is related to the lithology. Yes, so potassium, thorium, and uranium, as I told you, has the emission of gamma rays in MeV 1.46, 2.6 to 0.6. MeV stands for millions of electron volt. That is the unit. Now, potassium is measured in percentage, whereas thorium and uranium is measured in ppm. Okay, so thorium is nothing but ppm is nothing but parts per million. Okay, now, so each of the above mentioned radioactive minerals give a gamma ray of unique energy. As I told you, it is 1.46, 2.62, and 0.6. So all these stands for unique energy. Potassium gives gamma rays of particular energy. Okay, whereas uranium and thorium they give us spectra of gamma rays. That is the reason why uranium and thorium is measured in ppm and potassium is measured in percentage. See, if a spectral gamma ray log indicates the presence of potassium and thorium together with uranium, it may be that the potassium and thorium contributions are associated with the clay content of the shaley carbonate, while the uranium is associated with some organic source which was deposited in a reducing environment that favors the conservation of organic material. So this is the reason why we consider only potassium and thorium, and we do not consider the contributions of the gamma ray by uranium, because potassium and thorium is associated with the clay content, whereas uranium is associated with some organic source. Okay, reducing. So there are actually two types of environments: reducing environment and oxidizing environment. Now, reducing environment is in the absence of oxygen, and oxidizing environment means in the presence of oxygen. Now, which this organic source which is present, if it gets deposited in the reducing environment, only then the source material will be converted into hydrocarbons. Now, before I come to this diagram, let me explain that uranium has affinity towards marine shales, whereas thorium and potassium have affinity towards terrestrial sediments. So, if we take a If we take the ratio of thorium by uranium, we will get from where the sediments have come from. That is, whether from the land or the sediments has been brought by the marine conditions. Now, but in this present study in the Rana subbasin, uranium content is less than 1 ppm. It is usually less than 1 ppm. So, thorium by uranium ratio has no meaning in using thorium by uranium ratio in it. That is one thing, okay. Now, when we talk about potassium, yes, potassium is also a radioactive element, and it is usually measured in percentage because potassium has a discrete energy. And yes, here, so you have potassium and Pe. Pe stands for photoelectric absorption coefficient. Pe stands for photoelectric absorption coefficient. Now, this particular thing is measured by something called I won't say more advanced law, but it is measured by the lithodensity law. Now, the basic difference between density log and the lithodensity log is the density log, it is affected by the lithology and also the porosity, whereas this lithodensity log is not affected by porosity. It is affected only by lithology. So this Pe measurement over here we get from the lithodensity log. Now, yes, now in density log what happens? The gamma rays are emitted from the source and it interacts with the electrons present in the atom of the formation. So when they collide, what happens? The energy get reduced. The energy of the electrons get reduced. So electrons get reduced, and when the electrons loses its energy, then we have a photoelectric absorption coefficient. Okay. Maximum energy, that when it produces maximum energy, we have photoelectric absorption coefficient. Then for this lithodensity law, it is measured from 0 to 10. Zero to 10 bars per electron. Okay, so sandstone have a value, limestone have a value, and also shale have a value, and different values, and dolomite has different values. For example, sand value is 1.81, then you have limestone that is 5.08, then you have dolomite which is little higher than the limestone value. So the P log comes from here. So as one could see here is clay minerals which are present are nothing but montmorillonite, illite and kaolinite with little presence of micas and chlorides. Now again I have drawn a graph between Pe and thorium by potassium. Now one may get doubt that earlier I have done with Pe versus potassium and now I am doing with Pe versus thorium by potassium. It is because when we use so many plots, the result will be easy to determine. This is the basic reason why I have used so many logs, so that the end product, that is the result which we get, is 100% accurate. So earlier I have taken Pe versus thorium, potassium, and now I have taken Pe versus thorium by potassium. Here also the points lie mainly on the montmorillonite, illite and kaolinite. Now for my study, this natural gamma ray spectrometry log was carried out only in 4 wells. Okay, that too in the Kanchanaburi field. Now Kanchanaburi is a petroliferous field, mostly the production of gaseous hydrocarbons. And in Kanchanaburi field, only in the 4 wells the NGS log was recorded. Now, this is how the NGS log looks like. We have ratios and then we have individual. Okay. So earlier slide I have shown you, right? Thorium by potassium. So thorium by potassium we can take directly from this here. And before that I have shown one more slide, that is Pe versus potassium. So the potassium value we can take from this track. Okay, and Pe, as I told you, we take from the lithodensity law. Now, so kg, so I have for confidentiality purpose, I have changed the names of the wells. So I have done in kg AX, BX, CX and DX. Okay. Now, this is basically done in the NGS logs, was basically carried out in Nanninam formation. It is basically called as Lithostatigraphy. I'll write it down. Lithostatigraphy stands for is nothing but from bottom to top. It is not that we have only sand, complete sand, or we have only complete shale or limestone or dolomite. Okay, so for suppose sandstone is present from one particular depth to one particular depth. On above we can have limestone. On above that we can have sandstone. On above that we can have dolomite. Now this is what is called as lithostratigraphy. That is lithology from bottom to top. Okay. Now for that, it is the names given to that lithology is area specific. Since Kaveri Basin and in particular Ramnath sub-basin is present in Tamil Nadu, so they have given Tamil names. So we have something like at the bottom we have basement, then we have Satapadi shale, Untitled formation, then you have Satapadi shale, then you have Bhuvanagiri, then you have Kudavasal, then you have Nandilam. Nandilam and Bhuvanagiri are basically the pay sands in the Ramnath sub-basin. That is, Nandilam is basically sand and Bhuvanagiri also is basically sandstone. Now, using this, the beauty of using NGS logs is nothing but we can divide within the Nandilam formation. Now, there are usually two basic terms. That is Nandilam formation and Nandilam pay sand. The basic difference between Nandilam formation and Nandilam pay sand is Nandilam formation, for suppose it encounter from 2000 meters to 1000 meters, that is 1000 meters. So we say that Nandilam formation is 1000 meters. But the Nandilam formation entirely, it doesn't mean it will contain only sand. It may contain sand, silt, clay, and it may contain some limestone also. So, Nandilam formation is a mixture of everything. But when we come to Nandilam pay sand, in Nandilam pay sand, we have only sand, okay? And hydrocarbons are usually present on land. Hydrocarbons are usually present in sand. So that is what we want to find out. The beauty of the natural gamma ray spectrometry log is within the reservoir or within the Nandilam formation, we can subdivide into shale. Then you have lower gamma ray. This is the reservoir. Then you have upper gamma ray. So we can say that the reservoir is sandwiched between the lower gamma ray and the upper gamma ray. The same way, this is another well. So this is the Nandilam formation. Okay, this is the Nandilam formation, and the Nandilam formation I have subdivided into shale, lower gamma ray, reservoir. Now, why is we are concentrating so much on the reservoir is because hydrocarbons are present only in the reservoir. Because reservoirs are porous and permeable. When a reservoir is porous and permeable, the hydrocarbons will migrate from the source rock to the reservoir rock, and when we drill a hole, when the reservoir is permeable, they flow into the wellbore and to the surface. That's why determination of reservoir is very important. So this is, otherwise it is also termed as net pay thickness. Net pay thickness. Net pay thickness is the thickness of the reservoir where we have the presence of hydrocarbons. That is the net pay thickness. Yes. So here I told you why we don't take uranium. Why we did not consider uranium here, because it is less than 1 ppm. So we have used thorium and potassium ratios. So you can see here, this is the kaolinite line, this is the mixed layer clay, halite, montmorillonite, chloride, mica, glabonite, this is potassium evaporites. So montmorillonite, halite and kaolinite are the dominant clay minerals which are present in the Nandigram formation. And the depositional environment is open marine. What is open marine is, on one side we have land and on the other side we have ocean. So the sediments are deposited in the this Kanchiramudi field, Ramnath subbasin, with the open marine condition. Okay. They are not deposited in the open marine conditions. Now, if we see over here, the thorium content is less than 20 ppm. If the thorium content is less than 20 ppm, it means that the sediments are derived from the terrestrial, that is on the land. Okay. So if the thorium, that is a thumb rule, that if the thorium content is less than 20 ppm, it means that the sediments are derived from the terrestrial, that is land. Now, why is thorium so significant is nothing but thorium is completely insoluble in the formation waters and it can travel through large distances without going into the solution. Okay, and thorium can also be used as a baseline from which we can determine the presence of the uranium present in the shales. Now, here I would like to add is we have something called radioactive sandstone or limestone. I told you in the beginning slides that radioactive elements, basically thorium, potassium and uranium, may be present in the clastic or non-clastic, that is sandstone and also in limestone. So how do we differentiate is nothing but when we see the gamma ray log, we cannot differentiate. But if we see other logs, that is particularly neutron and density log, we can clearly differentiate a radioactive sandstone and limestone from a shale. So here, the clay minerals is nothing but montmorillonite, halite and kaolinite with very little presence of mica and chloride. Now, as I told you, since I have carried out this logging in 4 wells, that is KJ, AX, BX, CX and DX. In KJ, AX and BX, montmorillonite and halite are the dominant clay minerals with the presence of kaolinite is minimal. When we go to the CX well, montmorillonite and halite are again dominant with subordinate. Okay, that is very less presence of what you call is the very less presence of kaolinite. When we go to the well called KJBX, mod morillonite and illite are the dominant clay minerals with negligible or complete absence of the kaolinite. Why? Is because this kaolinite has been transformed into mod morillonite under high temperature, pressure and pH conditions. That is the main reason behind the subordinate presence or complete absence of kaolinite in various wells of Kanchanaburi field. Now, mod morillonite and illite are the dominant clay minerals which are present. Okay, which are present in this 4 Kanchanaburi wells. Now, I told you kaolinite has transformed into mod morillonite under high temperature, pressure, pH conditions. Okay. So this is also another well which we can see the presence of various radioactive elements. Yes, here since I have taken a very large interval, so we have the concentration of points mole over here. Yes, the conclusions which I have drawn is nothing but natural gamma ray spectrometry log shows that thorium is the dominant radioactive mineral contributing to natural gamma ray radiation in the nonylum formation. Potassium concentration is close to normal 3% and rarely shows up to 5%, whereas uranium shows very meager value. I told you is less than 1 ppm. Therefore, thorium by uranium ratios are not significant in the present study. I told you in the previous slides. Then thorium by potassium ratios indicate that mod morillonite, illite and kaolinite are the main clay minerals in the nonylum sediments and are derived from acid igneous rock provenance, that is from the Pattukkottai Mannargudi ridge. Low or nil presence of kaolinite is inferred due to its transformation into mod morillonite under marine and illite under high pH temperature and pressure conditions. This also I have told you. The low concentration of thorium, that is less than 20 ppm, suggests that the sediments of the nonylum formation were deposited under open marine conditions, as I told you. Finally, I would like to thank the management of the Amet University, my HOD and my other colleagues. Because of them, today I have presented this. Thank you so much.